Hello and welcome. Welcome, everyone. Welcome to this very special episode of Iron Beetle. So, usually, Iron Beetle is a show where we look at how Tiger Beetle database, this exciting new database for financial accounting implemented in Zik, is working inside. We really, just disassemble the whole thing and then reassemble, coming away with a full understanding of how to build a modern, distributed, highly reliable database. But today's Christmas time. Well, maybe it is Christmas time for some of you. For others of you, it's going to be like New Year time. But anyway, end of the year, time to reflect, time to make promises for next year. So today's episode is going to be pretty special. We aren't actually going to be talking about Tiger Beetle, and rather the topic of today's episode is developer tooling. Before I started to do databases, I was doing IDEs for the Rust programming language, originally in JetBrains, working on IntelliJ Rust, and after that, working on Rust Analyzer. And before that, I actually spent a couple of years just working on my Emacs config. So I am I spent a reasonable amount of time, thinking about how to write code better, and I want to share the lessons learned today. So yeah, hopefully it's going to be fun, at least for some of you. And to start, why dev tooling is important? Why should we think about it all? Maybe we should just blindly type text or whatever. And the answer there was given by one character of Lord of the Rings books, Gimli, because once Gimli said that, hey, if I have an hour to cut down 100 orcs, I will spend the first 45 minutes sharpening my axe. Because this is this really is as a programmer, what you want to do is you want to solve some real world problem. Like in case of Tiger Beetle, we want to solve tracking of financial transactions. To solve this problem, you generally need to write some amount of code. You need to create a software. You need to create a specific repository which contains a certain number of lines of code which implement the game functionality. And creating this artifact is actually surprisingly complex. If you if you look at it, it's it's every program is super simple. It's just a string of characters on a string. Very little amount of data compared to let's say a movie. It usually is larger than a novel, but novels are not written by teams of people. Nevertheless, producing this artifact is pretty costly, and a lot of work goes into it. And actually, the most of work, most of cost is about solving coordination problems, making sure that the team of people can together work on producing the shared software, and making sure that the software actually solves the problem that needs to get solved rather than some unrelated problem. And we are not going to talk about this today. Today we're going to talk about this very mundane, very simple process of writing code and reading code. And it is in the grand scheme of things, it is not that much important. But in the small, if you could make this slightly more efficient, if you could accelerate this, and if you could remember those efficiencies and apply them again and again, you might actually type more code and solve more problems. So this is this is kind of the core idea here. The core idea here is of an investment. You invest some of your time into your tools, into sharpening your axe, sharpening your saw, and then as a result of that, you get to solve all future problems faster. But here, let me pull something onto the screen. So, okay, the first quote was from The Lord of the Rings, like how you should sharpen your axe. And there is, like, the complementary reference to this, to the popular culture, the XKCD, which documents like how much time you should spend on automation relative to the time it actually takes you to solve a task. Like, I mean, like, if you have like 10-minute chore to do, but you can automate it, and it would take you only 2 hours to write a program to automate this 10 minutes chore, but writing a program is fun and engaging, unlike actually doing a thing. And then, of course, you're going to write a program, which is like fun, but not necessarily most efficient. And I guess the biggest lesson, at least for me, is that you could reconcile those two ideas. It is true that, yes, if you improve something, then this makes you more productive, and that creates like compounding effects. So like from that perspective, like improving something, automating something is like always useful. On the other hand, it is generally true that writing automation is hard, that writing automations that like actually sharpening your axe so that it is like meaningfully sharper takes a lot of time, and it might actually take more time than like doing the task the dumb way. And the solution to this dilemma is that you could distribute your work. And the idea here is that you could, like, we do software, so you could, like, spend a lot of time sharpening your axe, and then you could put your axe on GitHub and let everyone else to clone your axe, so that everyone gets to use, better tools. So the big, and this is the big idea. So if you are drawn towards, like, instinctively towards working on tooling, towards like improving basic stuff, towards improving processes, then you should, like, again, you don't have to, like, if you want to hack on the tools just for yourself, and like, feel free to do this. But if you want to, like, make bigger impact to create more value for this world, what you could do is that you could find a way to scale your tools, to let yourself spend hours of your life hacking on some editor config, but then letting a lot of people use your tool for free. And this actually has a flip side, in that there is like a sort of productive mindset when you approach a new tool. So the idea here is that if someone gives you, like, a new shell or a new editor or a new large language model or like whatever, the idea here is that there is a group of people which made that tool, which are like really, really experts. And they, like, thought really, really hard about like what is the best way to use this thing? How can it actually accelerate your workflow? And then as a user, your primary goal isn't to, like, literally retrace their thought process, but rather you could be, like, very deliberate about picking up the fruits of their labor. You need to understand that, hey, actually all those people who put their thought into the tool, they had, like, certain ideal way in which the tool was used. And your goal is to figure out what is the intended way to use the tool, and then check if this is a good way for you or not. Because, okay, different people might need different approaches. Some people use Vim, some people use Emacs, other people use like VS Code, whatever. Like, those are all excellent tools. They have their own strengths and weaknesses. And it is important that you are, like, come to this landscape of tools not from a perspective like, hey, this is like one tool which, like, this is the right way to build tools, and everything that is like not VI, it is inherently wrong. No, you should approach this with a kind of like broader mindset that, hey, there's like different ways to solve the problem. And like, if you're really a fan of VI, they need to understand the appeal of Emacs. You shouldn't look at Emacs as a bad VI. On the contrary, you should like look for things which Emacs can do, but VI cannot, and vice versa. If you are an Emacs fan, and maybe even like, if you're like using evil mode, you should still take a look at those VI folks and try to understand what is the difference. Like you shouldn't try to approach any other editor as like a poor copy of Emacs. You should actually try to see what deficiencies in the Emacs get reflected in what other editors are doing. Okay. So as a start of like actual list of tools I use, let's start like with the shell. I'm using fish shell, and I'm using a fish shell not because it is like especially nice, a great shell. Like actually, well, I mean, I think like fish is pretty good as far as shells go, but in general, I'm not a big fan of the idea of a shell, or rather, I'm a huge fan of the idea of a text shell, but I'm very much not a fan of like the today's implementation, which is built on top of escape codes protocol, which emulates like machines which are no longer there. This like for me is like purely technical debt. So yeah, I'm kind of like use fish practically just because it is the best tool among like a bunch of like cron tools. But why I want to showcase fish is because it embodies that philosophy which I was talking about before very well, where the authors of a shell think very hard about what is a productive way to use the shell, what is the right set of defaults, how kind of like you could make someone productive even if they don't spend time configuring their shell and using their shell. And for example, like in fish, if I want to change to some directory, like for example Rust Analyzer, I like type, and here it is like with auto completion. Or if I want to go in target.bit, like there's like target.bit will work. It is right there, and there is no plugin here. This is just a functionality which is built in. And yes, you could have this in ZSH if you install almost ZSH or whatever. But that's not the point. The point is not like, hey, fish is capable of doing this. The point is that this shell does this by default. So the authors, and this small feature actually makes me place a lot of trust into the authors of the fish shell, because I know that, hey, those folks really think hard about how to make the shell useful for me. So I don't necessarily need to read a ton of man pages to go understand how I use it. I can rely on them to actually make useful features pretty prominent. Okay, so this is, I guess, the first two lessons. As a producer of tools, look for scaling your work and look how other people could use your tools without them spending equivalent time of actually understanding why the tool works the way it is. And similarly, as a consumer, look not only for tools which have powerful features, but look for tools which specifically built on the premise that they save you time by compressing the tool's author's knowledge and encoding it in the code, which just does what you need it to do, without actually, you spending a lot of effort learning it. Okay, so this is lesson number one. Let's go to lesson number two, and this lesson number two is actually something which I've learned maybe just 2 or 3 years ago, and this one I really wished I had earlier. And that lesson is build your smaller tools. So and here, like, we are going to look at our at my .files directory, and inside my .files directory, I have like this tools subdirectory. And what is this tools thing? Well, like, the idea is pretty simple. Like, I'm a programmer. Like, sometimes I need to do things. Like, for example, I need to do things with Git. And like, sometimes what I want to do could be automated. I could take some routine task and like write a small program which does it. And the lesson, which like really which took embarrassingly long time for me to internalize, is that you need to reduce the activation energy to write these kind of tools. So again, the idea that, hey, you should be writing tools, you should be writing your own scripts, is kind of like commonplace. Yeah, it's obviously good. But for most of my programming career, I wasn't actually writing like, this little thing is, because for a trivial reason that the activation energy to do this was very high. So for example, okay, let's say I want to do something with Git. Well, then I need to write this in Bash, and like Bash is kind of like horrible language, so I will like spend a lot of time learning about like ifs and whiles and all of these horrible like escaping rules, and like I can do this, but like it doesn't feel like a good use of my time, because here like the Bash feels like an obstacle towards me building my tool, because I'm going to fight with language. So okay, can I use other language? Can I use Rust? Well, I kind of like sort of could use Rust, but then its tool is a separate whole new binary, so you need to cargo new, and then you need to like cargo add some like clap or like whatever, and then you type, and like by the time you go to actually writing your logic, you're kind of like completely exhausted. So it's not that like Rust is bad choice for this kind of thing. I mean, what you're seeing is Rust. It's rather that like the activation energy is too high, and the goal here is to reduce activation energy. So kind of like to like more concretely, just make sure that you could really easy create a new program which you can then use in your shell. So for example, if you think that Bash is actually fine, okay, that is perfect. Then for you, activation energy is learning how to use if in Bash, how to use a for loop in Bash, and having some directory on your hard drive which is in your path and which contains your scripts, so that if you want to add a new script, then you just go and like copy paste the existing one or create a file there. My tool is Rust. So for me, the activation energy to add some new script, for example, for hacking in Git, Git, is that I already have this tool written. So like and it exists. So I could just like let's say I want to like implement Git absorb or something like that. I just copy it here, and then I copy it here, and I'm ready to go. This is really important, like for like figure out like which tools you should be writing, and then reduce activation energy for writing those kinds of tools. So let me show you specific examples. So one example is this like GG tool, which I use for like various Git automation. It doesn't matter like specific automations here. The thing is that like it's very easy for me to add new things here. The second thing here is like this config command, which is again like my small automation for like working with my .files repository itself. But the cool thing which it contains is that it has this multi-call module, meaning that if I want to add a new small script, I can just dump it with this pub create function run in the multi-call directory. and then I need to add this to this match statement, and then it's there. So I don't need to like have I don't have to separately start new project for this. Because I already have a project. This project already has dependencies for error handling, for parsing command line arguments. I could just write my scripts, and like this is like actually a very good example, because I have this infrastructure for adding arbitrary number of tools, but I only have one tool, which is called N, and this is like something I use with Whopper a lot. So if I need to run Whopper on some Whopper being the simulator. Okay, good note in the chat for zooming in, because this is not my usual. Okay, it should be better now. Thank you very much for noticing font size, because this is not my usual repository, and of course it doesn't have the right size. Okay, so okay, I guess the font size in the shell is also not very good. So let's. Okay. Okay, let's see if I do config. How to save config font size 20. I wonder if this works. Okay, yeah, it works. Okay. Where do I? Okay, yeah, the M tool. So the M tool is like very, very simple. When I need to run Whopper 16 times, I usually okay. Actually, see okay again. Like tools tend to build atop one another. Here you see I already have like in my shell history that hey, I would like to run Whopper, and I want to run this like 65 times. 65,000 times, and that is, I mean, that's it. Like the very simple tool. I mean, it's just a shorter for loop, but I use this tool like many times a day. And the big thing here is not that like this tool exists, but the big thing here is that I've lost my keyboard. Is that it is like one of the multiple binaries, and if I want to add another tool, well, I just go and edit, and that's it. There's like another example here. So there's like my code, which is VS Code extension, my personal VS Code extension, which I wrote just for myself. And again, like this is like one of the worst things about VS Code is that like all of the underlying architecture is like very dynamic and like very much like Emacs in some aspects. It is unreasonably complicated to just go and run your own code inside VS Code. VS Code is very hard to script in a naive way by just dumping some code there, because like it wants you to have an extension, it wants to have this extension published, whatever. So I just went with like this whole process, like this whole chore, like creating this like package JSON and like declaring dependencies, and there is like some command to actually go and install this extension, which I don't understand how it works. But then the result here is that hey, if I want to do something with my VS Code, I can now just go and drop some extra functionality here. And for example, just a small example of like one tool I use, which is pretty neat this way. And let's go to target it all. Okay. Well, let's go to the other target it all, which has bigger font size. Okay. What is happening here? Okay, so I have this little next menu. Like, in editor, like you need to navigate for things. And the more you use the editor, the more you realize that there's actually a lot of things you want to navigate through. So, for example, here, what are the things I can navigate? So there is navigation around errors. Like, I can go to the next error. Then there is navigation around changes. So I could go to the next change. Then if my file has merge conflicts, there is navigation around merge conflicts, and there is results of search, and then there's history across edits. So basically there's a lot of lists of things you could navigate through. And the way this is usually done is that next error has its own dedicated shortcut, and then next change has its own dedicated shortcut, and then next search result has its own dedicated shortcut. And by the time you get to the third or fourth shortcut, you completely forgot what are those shortcuts. So for me, I realized that I only navigate one of those lists at the same time. So I either go through errors, or I go through changes, or I go through references. So what I have is I rather have just two shortcuts. I have Control-N for next, and Control-P for previous. And these two shortcuts go to the next item in the list and in the previous item in the list. And what list? Well, the last one you've navigated. So if the last time I navigated to the next error, then Control-N will bring me to the next error. If the last time I navigated to the previous merge conflict, then Control-P would get me to the previous merge conflict. And then there is this little menu which allows me to choose once what I'm going to navigate through. And this is the tool. Where is it? Okay. Okay, it is not here. No, I don't want to say this. Well, while we're finding this tool, and I another small tool. I need to as you might have noticed, I like hacking on my config. So obviously, I want to have a easy way to open my config, so that I don't have to find this folder all the time. And well, there's config edit, which just goes and opens it. Okay, and this is was implemented in my personal VS Code extension, just one of the 3 or 4 features which it has. There is a list of things I can go through, and then there is this go function which dispatches on the current target, and then just delegates to some of the existing VS Code commands. Again, the idea here is not so much that, hey, this is a cool interface which you should use, but by the way, it is a cool interface and you should use it. But the idea here is that because I've paid these fixed costs of creating VS Code extension once, I can now very easily go and edit this kind of tool. Okay, so let me show another example of this idea of removing fixed costs, or making it really trivial to write new tools, removing friction. This is how I run the code, and let me see, do I have, no, I don't have make here, but I think, okay, yeah, here it is. So, when you, oh, what a perfect example. When you, working on software, sometimes you need to run programs. And like usually there's like two ways to run programs. Either you click some run button in your IDE, or you go, you open your shell and like, you find like the relevant command in the shell and you run it. But oftentimes actually like, you need to run several tools. Like, for example, you're working on a distributed system and what you want to do is that you want to run 3 nodes in parallel or something like that. And like, you kind of need scripting. And the thing here is that this there's like a giant jump in complexity between like, hey, I want to like run this command versus, hey, I want to like, run this command and like do some processing, because for later like you need script and then you need to, you end up in a bash land, which is like very horrible language, or you need like, in a full-blown like Rust land, but then you need to have like some prepared infrastructure like my multi-call thing, which is not project specific. So that is kind of like painful. So at some point, I realized that I actually can, like, write this around. So what I do now is that in the root of a project I'm working on, I have just a single file, which is called make ts, which is like TypeScript file. And it has a shebang for being run with Dino, and I can run it from a shell like this. And I also have just a single task in the VS Code to like this one to go and run this make. But the idea here is that, hey, this is now like a TypeScript program. So if I want to do something, I can just like, go and type here and get like, auto completion by the TypeScript. I get like, easily understandable for loops. I get async await, so I can easily like, span three processes and then wait for them all to be there. So again, this is kind of like, and here actually like the way I usually use this is just for running tests. So like I made some change to the source code, so I want to test it. So I type something like build test, and then some test fails, and I want to like rerun this test. So I then go and then this like test name, and now from this point on, if I rerun this make, I get to rerun this test. So this is kind of again, I kind of like called make, but it is in a sense it is the opposite of a make file, because the idea is that this script is mutable, and you always just like go and type your like persistent shell history there. Okay, and what we see the last time I was doing, I was debugging some bug, and I had like a giant log file, and I needed to like figure out which of the machines emitted many lines in the log file. So yeah, this is like a short script I've written. And again, the idea here is that I reduce my activation costs. I could have written this in Bash, but then I would have to actually know Bash syntax, which I actually like. I mean, I tried a couple of times, but really, it is pretty horrifically designed language. It really sticks badly inside my brain. So I went with TypeScript, and with TypeScript I get auto-completion. I get like this fancy library which can do like JSON and whatnot. And because I already have this single script prepared, and I already have all the commands for running the single script, like I don't need to create a new infrastructure for spawning things. Okay, so I guess this was the first half of the episode, which was about big ideas about tooling. I don't claim that I have a lot of big ideas, Let's recap those. So the first idea is that, yeah, kind of like, do you spend time sharpening your axe? Do you spend time working on the tools? Because it can make you more productive. It can make you write more useful code in the future. And like the meta level here is not so much actually like, spending time on tooling in particular, but just spending time and like spending mental effort on reflecting on your work process and realizing some ways you could actually optimize it. The second thing is that you could try to scale it up. If you are a producer of tools, then publish your tools as independent libraries. Publish your ideas as a blog post, like record Twitch streams. Get the ideas out there so that the next programmer doesn't have to retrace your path of trial and error and can see, like, what actually worked for you and make the decision for themselves. On the flip side, as a consumer, you really want to look for tools which are not powerful in and of itself, but rather condense the knowledge. The tool which lets you learn just a little bit of it, but at the same time immediately gives you a lot of power. And the third big idea, or maybe the fourth, I'm kind of like bad at counting, is that you want to reduce activation energy. If you one day wake up and realize, hey, I could write like this tool, and then you realize that to write this tool, like there is like 3-4 like boilerplate things, and by the time you stop thinking through those boilerplate things, you're already bored and you don't want to write the tool, then at that point in time, you actually should like do just a boilerplate and leave a template there, and then go to sleep. And next week, when the next week you would have an idea to write a tool, then you already would have all the necessary boilerplate in place, so you could just concentrate. Just on writing the tool. And this is like hugely important because it unlocks your motivation. It unlocks like more thinking about like, hey, now I could be writing models. Okay, so now let's get down to something like more fun, more hilarious, more flame baity maybe. Like, let's go to specific. Which editor should you use? And okay, this is kind of like really hard. I guess kind of like the truistic answer is that like there are different editors. All of them are powerful. Pick one and learn it like really, really well, and it will be the tool for the end of your life. Which is, I guess, like reasonable. For me personally, again, as a person who used like many different editors, like I used Emacs, I used VI a little bit, I used IntelliJ, I used Sublime Text, and I'm now using VS Code. Just Helix a bit, I think. It's the thing here is that I don't think we actually reached that point where we do have like like a good editor, which is like really like the last word, because infuriatingly different editors have like incompatible advantages. So what would be my like design criteria for an editor which I would be comfortable to say, hey, this is the editor I'm using, and I will be like using it like for the next 20 years or 50 years. And there is no such editor yet. Well, first of all, it's kind of like, it has to be GUI editor, because I do love text. Text is very powerful. So for example, when I need to work with Git, I do this through Magit interface, which is like, Emacs style text interface to Git. I don't use some kind of like GUI thing, because this is like really, really powerful. It's like really powerful that I could like, just hit tab there to see what has changed there, and then I hit enter and I go there, and without leaving my editor, I can control tab back to this list of changes, and then I could use like, page up, page down to navigate through this thing quicker. So this is like really powerful. And text is really text is like really great paradigm for doing programming related tasks. But at the same time, the way we traditionally do text is through this, is through the shell, is through and see escape sequences. And I honestly like don't think that this protocol is like the right thing. Like, it's a specific problem, kind of like, if I want to change the core theme, I need to coordinate the core theme between like my editor, my shell, and my terminal, and that is like, it is a giant mess. Because fundamentally, like, there just isn't a good factory in there which allows us to extract the theming concern out of the things, unless you want to stick to like 16 colors, which don't have well-defined meaning, because like everyone argues about like whether like dark gray is like white or black or whatever. So yeah, this is kind of like it is GUI, but it's also text. Then clearly the editor should have kind of like, now that we have this kind of like Emacs style rich text interface, which allows us to cast the entire editor, is mentioned, but it is also like running in this environment which is divorced from the shells and the terminals. This is going to be like pretty decent like thing to write your own tools inside. So there like needs to be like a scripting language, and kind of like like just like already if we are just at this reasonable set of requirements, you kind of like see that, hey, we actually don't really have good editors. Because if we take something like Emacs, then scripting language is kind of like it's language from the 20th century. It like Emacs Lisp was like good like 50 years ago, but it's not like really really good today. The same goes like for VI. Maybe NeoVim with Lua is actually good, but then it kind of like attached to this terminal paradigm, which again is not really forward looking. If you look at VS Code, it's kind of like, it's kind of like GUI, but it's not really good GUI. It is like it is like really a browser. It does way more than text editor needs to be doing. And a scripting language, like TypeScript is like not great. It is, I think, much better for these kinds of things than Emacs Lisp, in particular because you have types, so you could explore the API of the editor, which is not known to you, much better. But what kind of like significantly reduces the usability of scripting in this code is that you gotta place all your code in the extension. You cannot like write ad hoc scripts. Scripting is not something for the user of the editor. Scripting is something only for editor extension authors. And yeah, kind of like we are basically stuck here. So I'm not happy with Emacs because like the scripting language and also like the editing paradigm is kind of like outdated. I kind of like want to have Control-C, Control-V working normally. I want to have like multiple cursors, and you could have those things in Emacs, but like it's kind of like uphill battle. Like VI is great, and the model editing is great, Although I don't think it is like strictly required. But then kind of like VI is attached to the terminal, and I personally don't think the terminals. I mean, practically, if you only care about like being productive, then like go with the terminal. Although it is outdated, it is going to stay outdated happily 100 years in the future. Like there's no losing there. But if you also care, like I've like some like aesthetics sensibilities of, hey, the thing actually needs to be like reasonable and not a pile of hacks, then like terminal is out. And then like this code is like also like browser. And then there's like Z. Z is cool, but also they kind of like don't have extension language today, and they, for example, they don't have Magit, and I kind of like really need to have it. Okay, so bottom line, again, pick one editor. Don't listen to anyone. Just use what are you most productive with. If you ask me what editor you should be picking, my advice would be, hey, if you are like really serious about code editors, then you got to write your own, because there isn't one which is currently good. Okay, so next, I guess what I want to cover is also like the language server side of things. So assume we have like some editor, assume we have like some basic stuff like building, compiling, running in. Like how do we actually like write code? And here like you don't have to use language server. You don't have to have this like thing which understands the semantics of your program and helps you. But I think like it actually is pretty useful, especially for like navigating tasks. So for like just typing the code in, I don't think like auto completion buys you that much. Like in Emacs with just stupid word-based word expansion, you actually could type pretty fast. And again, assuming that like your baseline typing speed is not in the basement, but it shouldn't be. Like, again, I'm not the fastest typer. I kind of like type, I think, at like 80 words per minute or something like that, which is like pretty slow. But I was much worse before then, and I kind of like do think that like at least like 80, well, at least 90 words per minute is like what is really mandatory for like any working programmer. So I'm kind of like below where I wanted to be here. But anyway, typing isn't what you need to optimize, but you do need to optimize how you read the code. And let me show you some kind of like most impactful, at least as I'm concerned, navigation capabilities, which you really should be seeking in your editor. So the first one is that, of course, you should be able to open files quickly. And here, okay, let me maybe zoom. There is. Is there a zoom level UI scale? Okay, so okay, so probably sadly, I think I don't like super. I don't immediately see a way to like embiggen this command palette, but well, actually no. Actually, let's start with command palette. So this is like the most important feature any productive tool should have. Like there should be a way to find all the commands that the tool has by typing their fuzzy names. So if I'm like new TVs code, and I don't know the shortcuts, but I know that like go to definition exists. I can type this in the command palette and get the result. And this is like, the main tool, because it allows you to learn what the tool has to offer. And by the way, if you are using Mac, then as I've recently learned, this is actually pretty neatly built into Mac OS itself. So, let's say you are like in macOS browser and you want to pin the tab. So actually, what you could do is that you go to the help menu and then press type pin tab, and that's the same interface. So it's typing the command in and it gets executed. So naturally, I have this bound to the same shortcut in like my operating system and in my editor. Okay, so once you have command, what is your next most important navigation feature? Your next most important navigation feature is going to be finding files by their name. So for example, I know that somewhere in Tegrabito, there is testing variant of storage. I type te/store and I get into my doc website, but I also know that it is Zig, so I type .zig, and then I get storage, and also, hey, I see that there is storage checker also in the testing. So this finding is really the core navigation interface. This code hasn't built it. Something like VI, I think usually you want to implement this using fuzzy finder or something like that. But in any case, you do want to use this interface. The next step from navigating using files is navigating by actual concepts you have in your source code. By function names, by type names. And sadly here, for Zig, this is not currently implemented. So I'm going to show this using Rust Analyzer. Okay, so this same thing. You have this window where you could type fuzzy name of things. So let's say, I don't know, I want completion. Okay, so we see that there is completion analysis, completion config, completion context. So yeah, kind of completion analysis probably something which could serve you as an entry point. And again, the idea here is that it is a fuzzy search, so you don't have to know the name of the thing. You only need to know part of the name and maybe try different kinds of things. And this is ridiculous. So this is currently usually provided by language servers. I think the only notable exception there is Sublime Text. But the thing here is to implement this kind of functionality, you actually don't need full language servers which understands the semantics of a language precisely. You need only the parser and maybe even just simple regular expressions. And you need some sort of an index which watches your code base as it changes. And for command line editors, this is usually done with the help of a tags file. But the problem with the tags file is that, it is a static index. So you compute it once for your code base, and then it isn't updated. And there is, some hacks which just run it on a timeout or every time you save file. But as far as I understand, they're surprisingly, really surprisingly to me, there is no tool which tries to maintain this index incrementally, which tries to burn as little CPU time as possible while keeping the index always correct, which is actually easy to do. And I kind of like encourage you to, like, if you are an LSP hater and you want to stick to, like, simple tools, I kind of like encourage you to try to write simple text file. Okay, so this is like the second feature, which if you are not using in your workflow, you probably should be using it more, which is like finding a function, a type in the code base by its name. There is very closely related feature which actually does work in Zig, and which I use in my streams all the time. And this is essentially the same thing. Finding a certain symbol by fuzzy name, but in the current file. And this is even easier because you don't need to maintain index across the whole code base. For a single file, you could recompute it every time. Probably that is why it works in ZLS and the global index doesn't work. But this, I think, okay, this is called document. Go to symbol in editor. So the first, for those of you who are using this code, the first thing, the thing I showed before was go to symbol in workspace. This one is go to symbol in editor. Like, those are the shortcuts you should learn. And if your editor, like, doesn't have shortcuts assigned there, you should assign the shortcuts. And if your editor doesn't have this feature out of the box, you should figure out how to like get this feature either through LSP or like through some other thing, because this is like, really the force multipliers. And well, I guess maybe this is a good time to pause here, because I mean I could tell I could rant about like editors and whatever like forever, but we're probably going to have one more Christmas sometime in the future, and that might be a good way to continue this talk. So okay, let's quickly summarize like this like ranty tool related discussion. And sorry if like if you're looking for like some specific advice like how to use like VS Code efficiently or whatnot, and instead like you get into this like meta level discussion. But well, that's why it's Christmas special. So okay, tools. Do write tools, but be mindful that writing a tool is not necessarily faster than like doing the work once. So when you're writing the tools, try to find ways to make them scale. Try to find the ways to either share your tools with other people or try to find ways to use other people's tools. Writing tools is a skill. And the best way to like learn tool writing is to write more tools. And the best way to write more tools is to reduce the activation energy for writing a tool. If at some point in time you think, hey, it would be cool if I could do X, then at this point you should actually stop and reflect what prevents you from like doing the X. What are the extras? And then work on removing extras. And once you have reduced the barrier to entry for writing your tools, you will find yourself writing more and more of them. Okay, then specifics. We didn't get to a bunch of specifics because we've run out of time, but for the editor's question, it doesn't matter. Some people use VI, some people use Notepad, some people use VS Code, some people use Emacs, whatever. Don't take me using VS Code as some kind of like advertisement for VS Code. It is kind of like the least bad editor for what I'm doing, but it's like, very like shallow praise. Go like if you are really concerned about the state of the editors, then go and write your own. And finally, when you're using the editor, please remember that you spent most of your time reading the code rather than writing the code. So you shouldn't approach your editor from a perspective of getting the best autocomplete. You should approach your editor with a perspective of getting the best navigation. And the indispensable navigation feature, which is actually very simple and which doesn't require all that fancy machinery of language servers, is simple symbol search. You need to let a machine find like a class, a struct, a file, a function, a variable name, an interface, given short fuzzy search. This is a solved problem, and it should be able to. You should have this functionality in any editor you use. And if you don't have this, as perhaps one small actionable thing you could actually go and do today to improve your workflow. Okay, I guess with this, let's finish this, and Merry Christmas, Happy New Year, and see you next year, where we'll be continuing hiking on Chargabital some more. Thanks for joining and watching, and goodbye. Bye.